Autosar is a demanding standard in the automotive industry, which has become a must-know knowledge nowadays. Autosar architecture is complicated and not an easy topic to understand at the beginning, but if explained in a better way, it's quite easy. And about me, I'm Prakash with 8 years of experience in the automotive domain, working on Autosar for 2 out of the 9 Autosar core organizations. I'll take you through this course and explain the architecture in a better understandable way with live examples wherever possible. This course aims for freshers who are new to the topic and for people who already have some basic knowledge on Autosar. This course will make it very clear on what Autosar architecture is all about and where and how to apply them. In this course, we'll see all these topics in a very detailed manner. We'll first start with a theoretical session where we get introduced to the Autosar topic and see the advantages of having Autosar. We'll next see the Autosar layers one by one in detail, and we'll start with the BSW layer first. And then the application layer with a complete look into its configuration like component types, ports, runnables, events, connectors, and many more. We'll also take a deeper look into the center receiver and the client server interface, which we'll be using mostly in our software. We'll also be seeing how to design and choose the right components, ports, and interfaces with a live example use case. In the next section, we'll look at the RT layer and we'll see in detail on how RT takes care of the port communications and scheduling. After this, we'll see the Autosar methodology in very detailed manner, and we'll also take a live example to understand this. This will be a 2 hours of theoretical part where we understand all the concepts with short examples. The next is the demo section for the rest 2.5 hours where we'll take a new use case from an automotive application and design the complete Autosar software starting from the base MCAL layer to the application layer. And I'm not going to use any general Autosar editors over here for a demo for 2 main reasons. One is that they are overpriced for everyone to try if you're not working in an automotive industry. And the second, if although we have these tools, the configurations will be auto-generated by it, and what is generated is completely a black box for us. To overcome this, we'll be seeing the demo directly on the Autosar tags itself based on simple XML editors and Notepad++, which is easily available for all of us to learn and try. Finally, once we finish the course, we'll be very clear on what Autosar architecture is and the different layers of Autosar with good examples to interrelate with, and to write an Autosar software with simple editors. And thanks for choosing this course and wish you a good learning. Before starting with the course, I have a short recommendation on the best way to approach this course to get an effective learning. Like already mentioned, the course can be divided into 3 categories, which is the introduction, theory, and the demo part. The introduction will be quite generic on Autosar, which we'll be seeing first. And next, we get into the theoretical session where things get interesting and informative. Here, we'll be learning on what Autosar configuration is and its different features, methods, etc. And we'll also learn how to choose the right configurations for our application. During this theoretical session, we'll have lots of questions on the how to implement part, and this will be covered in the next demo session that follows. Autosar is quite a new conceptual topic, so please don't worry if something was not understandable in the theory, as the demo will cover the same topics in a practical way. So consolidated, 3 short hints from my side. Since this is a completely new concept, please take the course continuously without gaps so we don't miss the continuation and understand Autosar better. Second, while we are at the demo, please interrelate it with the corresponding topics that were seen in the theoretical session together. Third, in case you have any questions, Please feel free to post them on the Q&A section and I'll answer them as quick as possible. Although it's an online course, we'll try to make it as interactive as possible. Wish you a good learning ahead on the course, and please do not forget to put a thumbs up as the course progresses and your valuable rating really matters. Thanks, and we shall get started. Let's start with understanding few properties of the sender-receiver interface. It's a model for the asynchronous distribution of information where a sender distributes information to one or several receivers. The sender is not blocked, meaning it's an asynchronous communication and neither expects nor gets a response from the receivers. The sender just provides the information and the receivers decide autonomously when and how to use it. It is the responsibility of the communication infrastructure, which is the RTE, to distribute the information to the receivers. The sender does not know the identity or the number of end receivers as well. When a software component wants to send a data, we create a provider port on that component. The opposite side can be a different component who wants this data. Here, we create a receiver port on this component and connect it to the provider. This connection is called a one-to-one communication where we have one component sending and just one component receiving it. One-to-many or one-is-to-n type of communication is when we have one provider and many components to receive this data. An alternate possibility of many-to-one or m-is-to-1 type of communication is also possible for sender-receiver communications, where we have multiple providers with one receiver. Autosar does not support many-to-many or m-is-to-n type of communications. It's not allowed to have more than one provider and more than one receiver for the same data. From the configuration side, we first create the sender-receiver interface and specify the data that is to be communicated in the variable data prototype. The short name of the variable data prototype defines the name of the interface that is meant to be communicated. The additional properties of this interface, for example, its units, computational method, etc., can be provided from the application primitive or application record data type within the sender-receiver interface. We could also have multiple data being sent on the same port. For this, we can specify multiple variable data prototypes in the same sender-receiver interface. Next, we create a port on the component and link this created sender-receiver interface to it. This completes the sender-receiver configuration and the port linking for a software component. Composition is a software component type that clusters or aggregates other software components or compositions. In simple terms, a composition could be understood as a container that can hold a group of software components. Now, the connectors. We have been seeing from the last examples that communication is established through ports and data is passed from the provider port to the receiver port. In a live system, we might have thousands of provider ports and receiver ports, and who is connected with whom is decided from the connector configuration. A connector can be of either one of these three types: assembly connector, delegation connector, and pass-through connector. We shall see how to use these connectors with an example. Let's take two software components that has a sender-receiver and a client-server communication with two provider and two receiver ports. And we shall place them under a composition called composition 1. To connect these two ports, we can use a simple assembly connector. An assembly connector is used to connect two ports within the same composition. This is how the assembly connector configuration will look like. An assembly connector will bind a provider and a receiver port within it. Above in the configuration, we could see the composition software component for composition 1 created, and this encapsulates these two software components SWC1 and SWC2. Let's consider we have another component in the system called software component 3, and this is placed within a new composition called composition 2. If we have a closer look, we could notice that composition 2 encapsulates composition 1 as well. Like defined, a composition can have both components and compositions. Again, the same example. We have two ports from software component 3 to be connected to component 1 and component 2. We can't make a direct assembly connection here since both has different parent compositions. The rule for using an assembly connector is this, that the ports to be connected from software components should have the same parent composition. From our example, the parent of software component 1 and software component 2 are composition 1, and software component 3's parent is composition 2, and hence an assembly connector cannot be used here. To do this, we'll have to extend the existing ports to the outer composition using delegation connectors. Software component 1 and 2 have their ports extended to the outer composition using a delegation connector, and now composition 1 has these ports defined in it. A sample configuration on how it looks like in the configuration file is here. A delegation connector extends the inner port from the components to the outer composition. A new mirror port is also created on the outer composition, and the delegation connector connects this outer port to the inner port of the component. Let's look again now if the connection is possible. The opposite connecting ports for software component 3 are now available within the same parent, and we can now have an assembly connector between composition 1 and software component 3. The connection is complete now. An additional difference between these two connectors are that an assembly connector connects a provider and a receiver port, but a delegation connector connects the same port type, either provider to provider or receiver to receiver. Every port connection should finally end with an assembly connector configuration. Hope it's clear on when to use an assembly or a delegation connector.